Hi, this is Mr. King. We're going to take a look at the squaring function again, y equals x squared, or f of x is x squared if we use function notation. Specifically, we're going to pick up with the vertex form again, how we graph a quadratic function that's written in vertex form, and we'll touch on the analysis of quadratic functions a bit as we look at their parabolas. Just as a quick overview, we covered this in part 1 of this lesson. The squaring function has a very nice symmetric shape when we graph it. The parabola is symmetric about a vertical axis. And the thing about the squaring function that we see here is that when we put a number in, it can be negative, like -1. And when we square -1, out comes a positive. But if we put in a +1, out comes a 1 as well. And so there is this symmetry on either side of 0 for y equals x squared. Like so. So this is the basic shape of all parabolas. The only things that can change are where the parabola is located in the grid, whether it's a steep parabola, that is, it's stretched up, or maybe it's flattened out and it's kind of squashed down. And the parabola can also be flipped. And as we look at the vertex form in this lesson, I'm going to show you how we can write a quadratic function using vertex form that tells us a lot about what the parabola will look like and how to graph it. And it's basically a sketch graph, but how to do it really quite easily without making a table. So what I'd like to do here is introduce the vertex form. It's y equals a times x minus h quantity squared plus k. Now, A is going to do something special, and we're going to look at that soon. H is also going to do something special, and we're going to take a look at that first. And K will also do something special, and we'll take a look at that second. But we're going to leave A to the very last. It turns out A affects the shape of a parabola and whether it smiles or frowns. Okay, so in the graph below, which I've created in Desmos, we're looking at the mother of all parabolas right now. We're looking at y equals x squared right here. And this is the parent function of all parabola graphs. Now, vertex form, we can see I've built it into Desmos here, and I've got the same variables as we see above. We've got a, we've got h, and we've got k. And I'm going to experiment now. I hope this works. I'm going to go into Desmos and I'm going to try to record some live graphing within Desmos using the screen that we see here, and then we'll come back. Okay, so we are in Desmos now. I had to resize the screen slightly to the left, make it a little bigger horizontally. We'll see how that works out in the video. But right now we are looking at y equals x squared, but you'll notice there are two other things in this graph. There's a blue graph, which is coming from over here. That's our vertex form of the quadratic function. It's graphing that blue parabola. Now, right now, the a value is 1, if you look over here. And that means we're basically graphing y equals 1 times x. Well, h is 0, so x squared, and then k is 0. So the blue graph and the y graph are both y equals x squared right now, with a equal to 1. Now, if we change h, if we put, say, the number 1 in for h, well, actually, you know what? I'm just going to move the slider on h. So I'm going to go to the right. H is positive, so this will be like subtracting 1. Oops, wrong number. Sorry, guys. My bad. We'll look at that later. H is the next line down. As h goes positive, look what happens to the parabola. It moves to the right. So I've put in h equals 5 now, and look where the vertex moved to. The vertex is no longer at 0, 0, it's at 5, 0. So when we subtract a number from h, it moves the graph to the right. That's called a shift right by 5 in this case. That's a shift right by 5, also known as a horizontal translation. And that's achieved by graphing y equals x minus 5 squared. Now, if we add a number to x, so it's x plus 5, that's what, when the h value is -5, it's x minus a -5, so we get x plus 5. It moves the graph to the left. This is a shift left by 5. Now you'll notice the axis of symmetry, which is the vertical dotted blue line, it also moves, and it always goes through the vertex, always. But that horizontal translation to the left or right, it moves the vertex, it moves the entire parabola as one piece. Notice it does not change the shape of the parabola whatsoever. It just moves the vertex left or right. So now I've put the h value back to 0, and so now we're looking at two parent functions at this point. And this time I'm going to change the value of k, which is the number that's on the end here of this vertex form. Let's see what it does. So if I let k go negative, so in other words, this would be like x squared minus 1, x squared minus 2, x squared minus 3, 4, x squared minus 5, 6, 7, and so on. That does not change the shape of the parabola either. It does not move the axis of symmetry, but it does move the entire parabola downwards by 10. This is called a shift down, in this case by 10. More technically, mathematicians would call this a vertical translation by -10. Now, if we make it go positive and we go to x squared plus 1, plus 2, plus 3, plus 4, plus 5, and so forth, we can move the parabola up by a certain number, and that number is k. So that's our vertical translation. So h moves the graph back and forth, left, right. K moves the graph up and down. So those are two key translations that are built into the vertex form of a parabola. Now, we're going to do something that's pretty cool here. I'm going to put h in as 4, and I'm going to put k in as -7, -7, right there. Now look at something. At this point, and I'm going to take a picture of this, and we're going to go back into the notebook. Okay, we're back in the notebook, and I've got my screenshot from Desmos, the problem we were just working on, and notice something. With an a value of 1, so we haven't done anything with a yet, so the shape stays the same. With h is 4 and k is -7, here's what our vertex form equation or function looks like. I'll write this in blue. It is y equals x minus 4 squared minus 7. Okay, so that means the h value, which is being subtracted by x, the h value is 4. The k value is -7. The a value is 1 here. And the graph that results is this blue graph right over here. We can see the vertex is 4, -7. And do you guys notice that that 4 and that -7 give you the coordinates of the vertex? They do. So one of the beauties of the vertex form is the coordinates of the vertex are staring at us. So really what I usually tell students is this, and this is not getting too technical on this. Oops, lost my pen there. Let's see if I can get it back. There we go. Fix that 4. We need to take the opposite of the h value, so that's a 4. We take the k value right here, which is a -7, and those are the coordinates of the vertex. There they are, right there. Okay, and again, notice that the shape of a parabola is unchanged as long as a equals 1. Okay, that's important. So the shape is the same here. So this y equals x squared, if we just move it to the right and down, we get the blue graph. Okay, now we're going to look at a sort of a full-fledged vertex form quadratic function. This time we have an a value, and it's 1/2. It's the number right here. And because it says x plus 2, the h value is actually 2 because this is x minus a negative 2 in the vertex form. And then the k value is minus 5. So from what we've learned before, we're going to expect the vertex to be the h value, which is negative 2, followed by the k value, which is negative 5. Now the question mark is, what is that a value of 1/2? Well, I kind of spilled the beans earlier, didn't give you the specifics, but I said that's going to change the shape of the parabola. And there's no better way to do some exploration of this quadratic function than to go back into Desmos. So let me switch screen back. Okay, here we are in Desmos. I have turned off the graph for y equals x squared. And what I'm doing now instead is I'm letting the function y equals a times x minus h squared plus k, our vertex form quadratic function, be doing the only graph that we see here. And the other thing that I'm also doing, as I have before, is I'm showing the axis of symmetry and I'm showing the coordinates of the vertex and the label that the vertex, in this point, for a parabola that smiles, the vertex is the low point. It's got the lowest y value of any point on the parabola. So let's find out now what's going on with the example that we were looking at a moment ago. So it's x plus 2, so I have to subtract 2. The h value is negative 2, so that moved the vertex to the left by 2. The k value was negative 7, so I'm going to drop down the k value to negative 7, and so we can see now the vertex shifted left and down, and so those are two translations, a horizontal translation to the left by 2, and a vertical translation down by 7. A shift left by 2, a shift down by 7. My students can always say that in a class in normal non-COVID times. Now, a is still 1, isn't it? But in our function, a is supposed to be 1/2. Let's find out what this does. But think about it for a moment. What would it mean if we were to multiply the squared part of this function, the x minus h squared part, which in this problem is x plus 2 squared? What happens when you multiply something by 1/2? Well, it chops it in half. And since all of that 1/2 x plus 2 squared minus 7, all of that determines the y value. The y values, they shouldn't be as big, should they? Let's find out. I'm going to move a to a smaller value. And there's a at 1/2, 0.5. Notice what happened. Now, to help you see this, I'm going to graph y equals x squared again so you can see the shape of y equals x squared. I hope you guys notice that the shape of our function with 1/2 x plus 2 squared minus 7, it's wider. It's wider, but the vertex was unchanged. The h and k values didn't change, but the 1/2 changed the shape of this parabola. And we would say that that a value is a vertical compression factor of 1/2. In other words, it's pushed the graph outwards. It's basically not growing as fast. The y values, as we go out to the left and right from the vertex, the y values are going up more slowly as we push out to either side of the x-axis. That's what the 1/2 does. And since we're in here, I'm going to just show you what happens if a goes bigger than 1. Right now we're looking at a between 0 and 1. It's a fraction, and it makes the graph grow slower. If we make a go bigger, the graph steepens. That's a vertical stretch by a factor of 10 right there. And that's obviously a much steeper shape. The y values grow very fast, 10 times faster than they do with y equals x squared. And so the a value is a vertical stretch or compression factor. And we'll go back to the 0.5 here. And I'm going to take a picture of this and come back into our notes. Okay, we're back in the notes now. And here's our graph of y equals 1/2 x plus 2 squared. And I guess I grabbed a different number when I did the Desmos. I chose -7, so let me fix that. This number here needs to go to -7. This number here goes to -7. And this here goes to -7. And now we know that our A value is a vertical compression factor. Factors multiply things of 1/2. That flattens the graph. And there it is. So we see here, there's our vertex at -2, -7. The axis of symmetry is x equals -2, which is the x value at the vertex. That's true for all parabolas. And we now know what A does. We also learned in Desmos that the A value bigger than 1 is a vertical stretch factor. So all of this is discussed in a fixed page that I'll put into the end of the video that talks about the various parts of the vertex form. Just to give you a preview, there's part of it will look something like this: a times x minus h squared plus k. And this part here, there's a little note that says shape, but it has more information. This is, of course, this is our left-right, our horizontal translations, and over here, this is our shift up or down, our vertical translations. Now, there's one other thing we want to look at. So we're going to go back to Desmos. Okay, so here we are. We're back in Desmos again. And this time, it's going to be a parabola with slightly different parameters. In other words, different h and k values and a different a value. The a value is once again going to have the absolute value of 1/2. But we're going to do one other thing that's different. Maybe you can think of what that other thing might be. And I'm going to stop this video for a second just to recheck what the function is. Okay, so our function, it's going to have an h value of plus 1. So the vertex is going to move to the right by 1. And it's going to have a k value of plus 7. So that's going to move our vertex up by 7. So now our vertex is at 1, 7. And now I'm going to bring in the a value. Again, I said a moment ago, the a value is going to have an absolute value of 1/2. And you may have figured out that that means I'm actually going to go with a negative a value. Watch what happens. See if I can get negative 1/2. There it is. Voila! A negative a value is a reflection about the x-axis. It flips the graph. We now have a frowning parabola. This is how you make a parabola frown. And the reason this works, well, if you think about it, as we move to the left or right from the vertex, do we go up or do we go down? We go down. We go down because the squared part of the function is being multiplied by a negative. The squared part can never be negative, but when a is negative, the products of a times x minus h squared are going to go negative always. Or they could, the smallest could be 0 or negative. And so you could say never positive. And so this is why the parabola opens downwards. It is a frowning parabola when a goes negative. I'm going to capture this screen and we're going to go back into the notes again. Okay, so now we know that when the x value is a negative 1/2, we know that it's going to cause the parabola to frown. It's going to be a frowning parabola, or it opens downwards. And we know that the fact that a is has a 1/2 to it as well, that this will cause a vertical compression of the shape of the graph. So it's a wider graph than y equals x squared, which is over here. So that's what that 1/2 does. In fact, that's what happens when the absolute value of 1/2 is between 1 and 0. The h value here, well, it's x minus h, so h is 1, and the k value is 7. That puts our vertex at h comma k, which is 1, comma 7. And we see that that's true. There it is right there in our graph. And we see that the axis symmetry is x equals 1, which again is the x value of the vertex. And I'll write that down. One last thing I'm going to do here, this would be something we would cover much more if we were in school normally. We would talk about what the domain of a quadratic function is. Well, this graph, for example, goes forever. So does y equals x squared. All parabolas have a domain of all real numbers. So in interval notation, the domain goes from negative infinity to positive infinity. Now for our blue graph over here, the high point is a 7, isn't it? So the range, the highest y value can be 7. But the y values head down towards negative infinity when we think about how small, how negative they can get. And so we say negative infinity all the way up to, but stopping at that 7, which is in the vertex. That is where the range finishes off right there. The last thing I'd like to share with you guys is this final page, which I had created a few years ago, and I cleaned it up a little today, actually changed something a little bit, which is right over here. I added the word shape to go next to A, and here's my left right for what H does, and for K we've got our up down. Again, those are our translations or transformations. A very important concept in mathematics, and normally that would be an important part of our course that we would spend more time with. And so this is an overview of the transformations, vertical stretch or compression factors. So we have a stretch. Okay, let's see if it's here. Yeah, here it is. If A is greater than 0, the parabola will be opening up and we say smiling. A is less than 0, parabola opens down, and we could also say it frowns. So that's vertical stretch or compression, but there's more information I should include here, and it's this. If the value of A is greater than 0, I'm sorry, let me say that again. If the value of A is greater than 1, or if A is less than -1, we have a vertical stretch of the graph. However, if the value of A is between 1 and 0, and if we want to account for negative A values where there would be a reflection about the x-axis, we'd say the absolute value of A is between 0 and 1. This will cause a vertical compression, and that's when the graph gets flatter, when it grows slower, when the arms get pushed out. That pushes the arms out. And then we go to H. That's our horizontal shift, our horizontal translation. And we've talked about that. That's one of the simpler to understand than the compression or stretch factor. And then the vertical shift, the up or down, that's also a little bit easier to understand than what A does. And the one thing I don't think is in here is this. Let's show this. When the A value is negative, then the graph does this. It opens down, and that's a reflection about the x-axis. And that's an important concept. That's a key transformation. And the example here on this page, we see that just like in our example in our lesson, the A value is -1/2, and so the graph frowns, and it's vertically compressed by a factor of 1/2. Now the H value here is a 2, so the graph is shifted right by 2, and then the K value is +4, so the graph is shifted up by 4. And so there's an example of the vertex form in action again and how we interpret it. And that concludes our lesson. Thanks, guys. Take care.